Okay. Today we're going to find out how to find a limiting reactant to solve a stoichiometry problem. So if you look at the stoichiometry problem, it's right here. It says propane combusts in oxygen to form carbon dioxide and water. And then if 85 grams of propane reacts with 300 grams of oxygen, determine the limiting reactant, and then you need to figure out how many grams of water are produced, whichever one with the limiting reactant. And you can't just say, I'm going to choose one of them. We got to choose which one is going to run out first. And that's the first one. And here's the way to figure out which one's going to run out first, is by these four, I'm going to say simple steps, but they're not all that simple. The first thing we have to do is we have to balance the chemical equation. Then we're going to find the moles of both or all the reactants, or whichever ones are involved, if there are reactants. So in this case, we have 85 grams of propane, that's one of them, and then 300 grams of oxygen, that's the second one. So those are our two reactants, so those are the ones we're going to find. Then we're going to take one and we're divide by the moles of the coefficients from the balanced chemical equation. Okay, divide each one by the moles of the coefficients in a balanced chemical equation, and we have to have a balanced chemical equation. And then at the end, whichever one is smaller, that's the limiting reactant. That's one that we use in our stoichiometry to finish the rest of the problem. Okay, let's go ahead and look at this one right here. So I have it already kind of laid out. Here is the first, or the equation. It's a balanced chemical equation already. So it's propane plus oxygen equals carbon dioxide, excuse me, and water. So I have two A's up here. Why do I have two A's? Well, we don't know which one's going to run out first, and we have to calculate which one's going to run out first. So if I had, in this case, I got to change this number right here. I have 85 grams of propane, but I have 300 grams of oxygen, and that's why they're underneath there. So which one's going to run out? It looks like oxygen is going to run out first, but it's a 1 to 5 molar ratio between the two. So for every 1 mole of propane, I need 5 moles of oxygen, and that's where we got to go to. So we're going to look at the first one here. And if I look at the first one, and I'm going to move this, hopefully that picture out of the way. There we go. And so we're going to go ahead and look at that first one. So to find the moles of propane, we're going to take the mass in propane. That's the mass that we start with, the 85 grams. And we're divided by the molar mass of proteins. Now, the molar mass of propane, I have 3 carbons. Each carbon is 12. That's 36 plus 8 is going to be 44. Okay, the mass in the problem is 85, so that's what we got right there. So the mass in the problem, 85 over 44. Now, what I really need to do here on this one is I'm going to take 85 and divide by 44. So 85 divided by 44 equals 1.9318, 1.931. We're good enough there. We don't need to go any further than that. I could put the 8 in there, but we're going to divide that by 1. So our number of moles that we have of propane is going to be 1.931. Okay. Now, if we have to go further, we'll go further with that number. So now we got to calculate out the number of moles that are in 300 grams, and then divide by our coefficient, which is 5. Okay, so this 1 mole, where did it come from? It was a coefficient in the balanced chemical equation, so that one came from there. So now we're going to do oxygen. So we're going to, the mass of the problem is 300. The molar mass of oxygen, O2, is 32. So if I take 300 divided by 32, I'm going to end up with 9.375, which still looks like it's a lot bigger than that moles of propane, but I have to divide that by 5. When I divide that by 5, I come up with 1.875 moles of O2. Okay, again, where did this 5 come from? It came from right here in the balanced chemical equation. From this point right here, we know that I've looked at it, oxygen is the limiting reactant. So if oxygen is the limiting reactant, I'm going to get rid of this right here, and we're going to use this one right here. So oxygen is A. So we're going to start with this. I'm not going to use this one because 300 grams of oxygen is going to run out first. And that's why we have to use the limiting reactant. So we didn't know which one we're going to use, but we calculated that out. That tells us that, oxygen is the limiting reactant. Okay, so now what we're going to do is we're going to come back down here and we're going to start with our 300 grams of O2. Now what we're going to be doing is we're going to be going using our stoichiometry map. Okay, so I'm going to bring our stoichiometry map in over here real quick. I don't know why everything else disappeared, but we're going to go from grams here all the way to grams over here. So 300 grams, we're going to do our molar ratio, so we're going to convert it from our molar mass in grams to moles. Then we're going to go from moles to A and B, okay, from A to B, and then we're going to convert it back from moles into grams using our stoichiometry map. So let me just get back out of there, pop the other one back up, and let's see where we're at. So right here we're going to put our times, and we're going to put 1 mole on top of O2, and we're going to put the molar mass, which we already calculated out was 32 grams of O2. Okay, and I might have to make these smaller just to make sure that they fit in there. We're just gonna smaller. Okay, so we're gonna come over here, put times, and now we're gonna do B on top. We go back up to our B is 4 moles of water, so I'm gonna put 4 moles of H2O on top, and we're gonna put our moles of oxygen, which are moles of oxygen. It's 5 moles of oxygen, so we're going to go back there. So we can put 5 moles of O2. Okay. Now I'm just going to quickly do some of this stuff that we need to do. We're going to underline both of those so we know that we're going to be doing. And again, we always multiply by the top, divide by the bottom. We cross off anything that we can cross off. So I have grams of O2 here, so I'm going to cross that out. Grams of O2 here, we're going to cross that out. Moles of O2 here, get rid of that, and moles of O2 here. Okay, so now it looks like I have it moles of water, but I need it in grams of water because that's what the question said, or asked for, right here, and grams of water produced. So now how do we do that? We go to the last stage of the stoichiometry map where we have to put moles on bottom. So we're going to come over here and we're going to put moles on bottom, so it's going to be 1 mole of O, our H2O, and I got to undo that. Okay, and on top we're going to put the molar mass of water. Well, the molar mass of water is 2 hydrogens, 1 each for 2, oxygen 16, so we're going to do 18 grams of H2O. Okay, and then we'll underline this one. Okay, I can get rid of moles of water right here and moles of water down here. Okay, so get rid of that, and I know that I'm going to end up with an equals grams of H2O, which should be the only unit left, and it's grams of water. Everything else is crossed off. So how do I get my number and how do I do these things? Well, we're going to do the math. So I'm going to bring the calculator back in. And what we're going to do is we'll clear that. We're going to start out with our 300. And I don't have to do the decimal. We multiply by the top, divide by the bottom. So we're going to divide by 32. Then we're going to multiply by 4, that's on the top. And then we're going to divide by 5, that's on the bottom. Ones we do not have to do because they don't change the effect. And so then the last one is going to be, we're going to multiply by 18. So we're going to multiply by 18, hit our equal sign, and we end up with 135 grams of water. So if I go back to the original problem, I have to make sure that it's in the correct number of significant figures. So I have 4 significant figures here, and I have 3 significant figures there, which means that my answer should be in 3, possibly 4 significant figures. Since we're using the 300 grams, I'm going to say that we need to have 4 significant figures because this is the one that we're using. This one is not involved in it. Okay, so we need to be 4 significant figures. So if I go down here and I look at this, this is my calculator answer, but my actual answer is going to be 135.0. Now that is significant, and it's going to be grams of H2O. There we go. That's our final answer. For us, we're going to highlight it, and make sure that we know where it's at. Here we know that we had to go over a place, so we know that we can see that if we had to shorten it up, we would put a line in there to show us where we're rounding. Okay, so that's the answer to that question. If you need any more help, please ask, and we'll try to provide it for you. Thank you.